We are working on the Minesweeper project from the YByte Python curriculum available at www.ybyte.in. Previously, we created this list of lists called field. The intention behind creating this list is that this is going to capture the entire information about our minefield. Remember, as we discussed, wherever we have a mine, we will have a 9 on this field list. Otherwise, for every other cell, we will capture how many neighbors does this, let's say how many neighbors of this particular cell are, let's say, bombs or mines. Let's get started with the first part of it, which is to say that look, on locations that are mines, I'm going to keep a 9 over here. But obviously to do that, I must first place my mines in this two-dimensional grid in a random manner. Now, clearly, we will need to import the random module for this. The approach we are going to take is that, look, there are totally, right now there are 81 squares. That's because my n rows and n columns is 9 and 9. So it's really 0 times, so 9 times 9, that's 81 squares. I am going to create all numbers between 0 and let's say 80. And from there, I'll pick up, let's say, n mines, which could be 10 to start with. Unique numbers, which will be basically the locations of the mine. So let's see this in a step-by-step manner. I am going to say, well, look, n mines, say n mines is equal to, let's say, 10. So if I want 10 mines, let's say, like I said, I will create all locations to be, using this comparison to say x for x in range, let's say, n calls times n rows. Now, in this case, it will be basically range 81, but in general, it could be n calls times n rows. From this list locations all, I will pick up n mines unique locations. In this case, 10 unique locations. The way I will do that is by using a very nice function from the random module called random.sample, and I just say, well, locations all, and let's say n mines. N mines. Now, as this description tells us, chooses k unique random elements from a population sequence. Basically, what it means is that I'm going to pick up n mines unique locations from this. Now, this has to be unique because basically we do not want miles to be falling on top of each other, and because that will completely break the game. Let's see this working. When I run this and I look at locations, you notice that locations are 10 values, and these values are all unique because these have been picked up from that list without any repetition. So they're all unique values. Random.sample has done that job for us. Of course, now the next step is to translate this into a two-dimensional position. The logic we are going to use is basically first figure out, okay, look, given that I have a certain location, let's say 19, which row does this number fall in? That's not too hard really if you think about it, because I need to just find out by row number by figuring out, let's say, the floor division or the quotient when I divide, let's say, 19 by n calls, or in this case, for example, 9. Having done that, I'll figure out the column index, and that will just be the remainder that I get when I divide it by, let's say, n calls. Which means that, for example, if I were to do 19, let's say, floor division 9, that is 2, and 19 modulo 9, that's a remainder, that is 1. So when I look at 19, basically I'm looking at, let's say, row 2, so 0, 1, 2, and column 1, that is 0, 1. That is basically, this cell. Now, let's understand this in a slightly different manner. Basically, this is 0 until 8. This is 9 until, let's say, 17, 18, and this is 19. So that's 2 and 1. Now, remember, using this location, we will update our list called field, because this location will directly can directly then be used to, let's say, index into that list and update its value. Let's see how we do that. Now we will have to obviously do it for every, let's say, every mine location. So I run a for loop. I say for location in, let's say, locations. So first I will find out the XY position corresponding to this location. So I go and do log XY. I can use this function called div mod because that will do the floor division as well as the, let's say, modulo in one operation. So when I do, let's say, div mod location, so location and n calls, it has to be n calls because I must do the modulo I mean the floor division as well as remainder with respect to the n calls. That's my row value. Let's first print this. So I just go and say print, let's say log xy. Now first we'll run the code until here. When I run this code, you notice I get all the log xy getting printed here, and I can corroborate them with looking at locations. First one here is 55. Well, that's because the first one here is 6, 1. 9 times 6 plus 1 is 55, and that is what I'm seeing here. Similarly, let's say the last one here is 4, 3. That's because it's 39. 9 times 4 is 36, plus 3 is 39. So, in other words, by doing a div mod, I have converted each of these numbers into a tuple, which tells me the row index and the column index. And once I know this, clearly I can just go and update my field list. So I just go and say field, for example, log, say xy, say 0, 0, and log, say xy, say 1. Now remember, field is a list of lists, so I have to be a little bit careful while indexing it. I set this to 9. Also keep in mind that we have taken care previously when we initialize, let's say, the field list, to make sure that there's no shallow copying going on, and hence this operation can go on, let's say, correctly. When I run this piece of code, now again, obviously random numbers got generated, so these are my, let's say, tuple locations. When I look at the list field, you notice, so I can look at, let's say, display field. You notice I have, for example, at, let's say, 1 and 4. So let's look at this one. Row number 1, 0, 1, 2, 3, 4. I have got a 9 over here. Let's look at these two. So that is basically 2, 3, and 2, 4. So, every location there has been translated into a tuple, xy tuple, and those xy locations, those row and column values, you notice have been converted into 9. So this field now contains all the information that we need with respect to the location of the mines. Of course, now we will go and build the, let's say, the neighborhood information. Now, before I wrap this up, I want to leave you with the food for thought, something for you to think about. You notice that the way we have generated these locations is that we took numbers from 0 to 80, 10 numbers, and then we just translated them into, let's say, a two-dimensional grid. The thing to think about is, what is the probability that I end up with all the mines, let's say, on a single column or a single row, or let's say highly concentrated, let's say, in one zone of the board. So for example, 10 mines, what is the chance that I'll end up with these 9 as mines? This one also as a mine. So that will change the game dynamics completely. That kind of almost break the game. But convince yourself, perhaps work out the probability, happy to discuss, that the chance of that is in fact very, very low. You have played this game so many times, that has never happened because the chances are very, very low. It can happen, definitely, but the chances are low, which is why we don't need to do anything special to handle that case. Like I said, I'll be happy to discuss if you want to, let's say, compute those probabilities and so on. But I hope you found this interesting. Let me just leave a small comment here. Say update the field list. And I will remove this print location xy and just instead say, well, mine. So because remember, mine is 9. So that, a little bit of comments always. I hope you found this interesting. In general, making activities, thinking about them is a great way to learn programming. That is how we learn programming at YByte. Look at our website, www.ybyte.in. We learn Python programming through such fun activities and discussing carefully about them. Take care. Thank you so much. Bye-bye.